This is the bubbles, and I guess one more bubbles lab. I just like to type the word bubbles. So here is our question. Does the amount of dishwashing soap change the diameter of the bubble? Now, if you do not know what a diameter is, you should draw this picture. A diameter is the distance across a circle, the middle of a circle. So going from this side to that side. And yes, I know that looks like Baymax's head. Hello. I'm a diameter. Alright, so from our question, what is going to be our independent variable? Well, the independent variable is the variable that you change on purpose, and what we are going to change is the amount of dishwashing soap. And so that is our independent variable. What about the dependent variable? What is going to be the thing that we measure? I kind of already told you about it because we drew that picture. That's right. We are going to measure the diameter of the bubble. The diameter of the bubble. And we do need controlled variables, so I just had this line go all the way down. When you are thinking of controlled variables, try and think of them in order of most important. What do I need to keep the same? Because if it changed, would change the data that I got on my diameter of bubble. Okay, so one of them, we need to use the same type of soap. We're not changing the type of soap, just how much of it we have. Type of dish soap. Another really important one is going to be the amount of the water. If we kept adding water, we would be diluting the dish soap. So those are going to be two important controlled variables. Now there are others, but these ones are high up on the importance list. All right, a hypothesis. Ooh, focus. Sorry, take my hand out. Needs to be in the if, then, because. So if, then you're going to use the independent variable, then dependent variable, right? So if independent variable, then dependent variable, because why, period. And that will be your sentence. So here's one that we came up with in second period. If the amount of dish soap is increased, right, if independent variable, amount of dish soap, then the diameter of the bubble will also increase, comma, because there will be more of a reaction between the water and soap molecules. So that is going to be our hypothesis. It does not have to be correct. I'm just trying to back it up for you guys to copy down if you need to. It does not have to be correct, but it does have to be written correctly. All right, and so here are the materials that we are going to have. We are going to follow the procedure. Add 1 pipette of dish soap to the beaker of 100 milliliters of water and stir gently till the soap is dissolved. So let's do that. Okay. So there's the soap. I'm going to stir it up gently, trying not to make a lot of bubbles. Keeps coming out. All right. All right, prepare this table surface by using 1 pipette full of the solution. Squeeze it onto the table. We're not going to spread it around though. So we're not going to do that part. Oof, I can't cross. And then we will dip the straw into the bubble solution. Probably won't practice. Blow a bubble until it pops. And then we will measure the diameter in centimeters. Okay, here is the solution on the table. I'm going to dip it so that I have a, bubble. All right, let's try and do this and record at the same time. So here's the diameter of the circle left by the thing. I did not think that one was ever going to pop. Sorry you guys missed it. I accidentally hit pause. My bad. But we are going to measure it with our string and then use that to check against the metric ruler. Right, so here's the string going across the diameter. What I'm going to do is I'm going to move it down and then measure it. Okay, so you can see that it is going to be more than 30 centimeters, so I'm going to need to move this down. Hold, please. And so on the back, our first trial 1 for 1 pipette was 32 centimeters. That is huge. Let's try it 2 more times. So you can see the diameter of my new bubble. What I did was I just used the soap that was on the table, and you can see that that is a lot smaller. So what I think I'm going to do is for each trial, add a new pipette. I'm going to clean the surface and add a new pipette of the solution, because that is going to be more constants that I keep the same for more accurate data. All right, that is a lot better. So let's, still have a straw in my mouth. Let's measure this one and get the diameter. So the diameter for bubble 2 is only 26 centimeters. No, I'm not on my finger there. So let's do it one more time. Okay, trial 3 was 25.3 centimeters. So these are closer together than that one. That one, superstar bubble. All right, if you are pre-AP, you will need to find the average diameter. We will do that at the very end for you guys. Let's go on to 2 pipettes. What we're going to do is we're going to add 1 more pipette of soap to our water solution and stir it up again. All right, there is the diameter for the first 2 pipette trial. Let's measure the diameter. Diameter. All right, so what I did was I just went ahead and did all 3 trials, but you can see that the bubbles got smaller. The air did kick on here, which is why I think these ones started getting smaller also, but 2 pipettes is smaller than 1 pipette. You can see it's just a cute little adorable thing. So let's see if the trend continues with 3 pipettes. Okay, so here's the data for the 3 pipettes, 24.8, 22.3, and 20.7 centimeters. It's very weird data. It doesn't seem very consistent at all, but let's find the averages. So for the average, what you're going to need to do is add all of these up and divide by the number of trials. So we did 3 trials, so we're going to add these up, divide by 3, and that'll give us an average. And we'll do the same thing, and we'll see if that makes a difference. All right, so here's the averages. 27.8 centimeters for 1 pipette, 18.4 for 2 pipettes, and 22.6 for 3 pipettes. So not really what we would expect. If you do remember, I did say that the air did kick on, and I could see the bubbles moving, so maybe that made a difference. This would really be a trial that I would want to repeat and try and have more controlled variables so that I could see if the data accurately reflects just adding soap. Okay, to set up our graph, the independent variable always goes on the x-axis. Well, let's not say always, but like 99% of the time. So, and you have to label it the amount of soap. 1 pipette, 2 pipettes, 3 pipettes. The dependent variable is going to go along our y-axis. And it says in centimeters. You need to qualify what your units are. And then you need to pick a range that's going to cover the majority of your graph so that everything's not squished in one spot, right? So I looked at my averages because I'm going to graph the averages. This is going to be my pre-AP one apparently because I just realized I need to have a grade level paper. So I will add that. Dang. Time flies, eh? All right. We got to wrap this sucker up. Yep. So I'm going to graph all of this on here and then I'll tell you what's what. All right. Took some time to think while I made these graphs. Isn't that pretty looking? You should have your bars large. They should each look a little different so that it's pleasant to look at and easy to differentiate. So we did the averages. And I guess in my grade level classes, we will do the averages together. Pre-AP, you will take your average and this average. We'll figure it out together, right? So here are my graphs. 1 pipette, 27.8, 2 pipettes, 18.4. I don't think we can draw a conclusion on answering this question or not. I think there would need to be more experimentation and data because this is not conclusive. Does not look like there's a yes or a no. Okay? You are going to need to write your conclusion on yourself. Write a sentence for each of the bullet points on a separate piece of paper, right? Because there's not enough space right there. And then attach it. So you need to say what you did in the lab, or if you are watching this video, what you watched that was done in the lab. State the purpose of the lab. What was the question we were trying to answer? Okay? Rewrite your hypothesis. Was the hypothesis valid or invalid? Or I'm going to say inconclusive. That means there wasn't a yes or no answer. It wasn't valid, it wasn't correct, it wasn't invalid, it wasn't wrong. At least not that we can tell. I would say that this is an inconclusive. Our hypothesis was inconclusive. And then prove that. Describe the results of your data using data from the data table to support your claim on why it is inconclusive. Okay? Once you have written your sentences for each of these, check them off because that will be part of the grade. Remember that this is due 10/4, right? 10/4, guys. Friday. All right. Miss Henderson out.